Hi-de-o neighbors, Mr. O is back. It is Unit 5, Lesson 4 time. And this time we are going to do more on the elimination method. So that's our objective once again, to solve more systems of equations by using the elimination method. This time we're going to get a little more of the multiplying piece, but we should have some fun. So hang in there. Let's go to exercise 1. All right, here we go on exercise 1. They want us to take the equation and do it twice, the one eliminating the x and the other one by eliminating the y. So if I take a look at this first one here, you got 4x as your x, and the other one is a negative 2x. Well, it should clearly come to your head right away that you know that what I have to do is multiply the second one then by 2. This way, I don't touch the first one, so 4x plus 5y is equal to 12. And then the second one now is going to be a negative 4x. It's going to be a plus 2y. And it's going to be a positive 16. Create that y a little better there, and that x maybe a little better. All right. What happens? Obviously, the x's are gone. That was our goal. What's 5y plus 2y? 7y. And what's 12 plus 16? 28. Divide by 7, divide by 7, and your y will turn out to be 4. Once I get that, you know that's only part of the answer, so I got to plug it back in. It's really up to you which one. Since the second one here has a single y, and I don't have to multiply, I'm going to use that one. I like that a little bit better of choice. So I will take negative 2. Cancel that out. Don't know what's going on there. I will go back to this. Sorry, I was going to text on you. I will take the negative 2x, and then we know our answer for y is 4, so plus 4 has to equal 8. And I will move the 4 to the other side by subtraction. I get negative 2x equals 4. And so x turns out to be, once I divide by a negative 2, divide by a negative 2, I actually get x is a negative 2. So my answer is negative 2 comma 4. So that's our solution. Now, they want us to do the same thing by the second part, but get rid of the y's. Well, if you take a look at the y's, you got a 5y here and a 1y there. The easiest is to get that one also to be a 5, but the opposite sign, because you got to have them cancel. So if I take that back here, we go take a look, I will multiply this line by a negative 5. So once again, I will rewrite the first line, 4x plus 5y equals 12. And the second line here will become a positive 10x. And it'll become a minus 5y. And then it will become a minus 40. Well, when I combine them here, the y's fall out. I get 14x's equal, in this case, it will be a negative 40 plus 12, so that's a negative 28. Divide by 14, divide by 14, and x turns out to be equal to a negative 2, which is going to be part of the same answer, as you can see. Take that answer and plug it back in. This time, it doesn't really matter which one x. This has got a 4x to it. It's got a minus 2. So if you want to try the other way, it doesn't matter. I'll take 4. Let's see here. I'll plug it in. 4 times a negative 2 plus 5y has to equal 12. That gives me a negative 8 plus 5y equals 12. Add 8 to both sides. 5y equals 20, divide by 5, and y is equal to 4. So we get the same answers. X is negative 2, y is positive 4, and that will give us the answer here. I want you to check your solution on your paper, but it is going to work for both. So let's go do that on your check, and then you'll join me right back here. Pause the video, and we'll go to exercise 2. Alright, now you're back here and you should have checked. It should have all worked out fine. Exercise 2. You will notice this time we're going to just do with the elimination method. It's not a setup for substitution. It's not set up for graphing. And the nice elimination is not going to work because there's nothing times 2 here to give me 5, and there's nothing times this 2 to give me 7. So we have to do elimination, what we call, Mr. Payne and I call, and Ms. Bell, a double elimination method. And what we'll do is this. I will multiply both lines. So if you take a look here, that one's got the 2. You take the 2 off of this one right here, okay? And you put it up here. You take the 5 and you put it on the other one. Now the problem is they're both equal to, they're both a positive, so I'm going to run a negative sign through one of them. It's really up to you which way. We also could have done this with the y's. So I'm going to rewrite these problems over here. And this one gives me, just going to be very careful in distributing, negative 10x. And then it gives me a positive 4y, and it gives me a negative 20. This line, when I multiply by 5, gives me a positive 10x, and you'll notice the x's are going to fall out in one moment. That's why we're doing it. 5 times 7 is 35y, equals, and then 5 times that's going to be, what I hear, 5 times 40. My math method is 200, and then 5 times 3 is 15, so 215. Big numbers. Well, when I go to add them, yes, indeedy, the x's fall out. If I add 4 y's onto that, it gives me 39 y's equals 215 minus 20. That's 195. Divide by 39 on both sides. Divide by 39. And y turns out to be, if it would have been 40 into 200, it would have been 5. But guess what? We're short 5, so that's 5 1. So it is going to be 5. A nice answer. So part of our answer, once again, is a 5. Well, what do I have to do still? Take that answer, plug the y equals 5 in, either one, it's up to you, and figure out the x. I'll write the first one again. So I'm going to take 5x, and then minus 2 times, I'm going to plug 5 in, equals 10. Only because it's smaller numbers, I'm going to pick that one. So 5x minus 10 equals 10. Ooh, looks like the 10s are going to cancel, but wait, they're not. Opposite of minus 10 is a plus 10. So you're going to get 5x equals 20. That's why we're doing it. And divide by 5. And x turns out to be equal to 4. Wise thing right here, obviously check your answers and make sure that they work. This is our solution right here, okay? So you can double check that on your own, and we will move on to the next exercise. All right, before we go on exercise 3, just want to let you know, you should have checked that, should have worked out fine. And just so you know, whenever you got to do that multiplication by elimination, you don't have to do the one line. Sometimes you're forced to do that too. It's actually a good method to do 2 all the time. It's a consistent piece, and you don't have to stop and think about it a little bit and figure things out. So feel free to do that. Well, anyways, in exercise 3 here, they give us 2 points, 2 sets of points, and they want you to put them both in y equals mx plus b form. So I've done the event thing and gone ahead already. So you may want to pause the video and start copying what I did. But the bottom line is I took, this is an x and a y, so I took the negative 11, put it in for y here. Took the negative 2, which is my x, and I put it in for x. I put the number first, always before the variable, just for consistent writing. And I did the same thing over here, 14 in for y, 3 in for the x, and you get those 2 equations. I then took these 2 equations, and I rewrote them over here off to the side, put them together. So now we're going to take a look at trying to solve this. Well, I love the addition method, and unfortunately, if I add, I still get an m, and I get 2 b's. But if you notice, the b's, they're identical, except we need the opposite sign. So all we have to do in this problem is basically multiply this whole line by a negative 1. If I do, this becomes then an opposite b, a negative b, and they're going to cancel. Well, if I multiply by negative 1, that just means go change the signs of everything. So I'm going to put a negative here, make that a negative here, and they're gone. When I turn around and add them, I get a negative 25 right here. I get a negative 5m. The b's are gone. I turn around and divide by a negative 5, and m turns out to be equal to positive 5. All right, now that we figured out m, we're going to take that m and put it back in for an equation. And I think, the first one, so I'm going to take that, keep that a negative 11 equals negative 2 times m, which is 5, plus b. So I get negative 11 equals negative 10 plus b. Add the 10. both sides. And I get -1 is what b is equal to. So my m comma b looks like this. It's an m is 5 and my b is -1. Not that you write it that way, because they want you to write the equation. So we know that's y equals mx plus b. So I need y equals, what's my m? 5 times x plus b plus a -1. There's the answer to this problem. Okay? So you can take any 2 points and actually throw them into the x and the y and the m and y equals mx plus b and do your solving. And that's a way of writing the equation if you ever want to, if you don't like to pick out the m and the b off the graph or whatever else. All right, we're going to move on. Exercise 4. Now, exercise 4 is the same as exercise 3, except they gave you a table format. So pick whatever points you want out. If you don't like the negatives, then don't pick that. Here's a couple of points here you can pick. You can pick this one, use those 2 coordinates, and do the same thing we just did in 3. Or pick whatever 2 you want. Go for it and do it. And Mr. Payne, Ms. Bell, and myself will all check out your work tomorrow on that. Make sure you showed us the exact same thing you got it. Okay? So do that. Pause this video, do it, and then we're going to move on to exercise 5. All right. Finally, in exercise 5, we are going to deal with a word equation. This is the sum of the larger of 2 numbers and twice the smaller is equal to 13. And then twice their positive difference is equal to 8. What are the 2 numbers? Well, we got to deal with, basically here, what are you going to let x equal and y equal? Well, I would let x equal, personally, the larger. So I'm going to write larger. And the y be the smaller of the 2. Well, the sum, that's the big key here, of the larger, which is x, of the 2 numbers, and means to add twice the smaller. Well, if the smaller is y, twice means 2y, is, you guys know, is equals 13. It actually says is equal to, so you can't go wrong there. Okay, there's one equation we just wrote. The second one says twice their positive difference is equal to 8. Well, the positive difference means the only way you're going to get a positive difference, a little trick here, is you can't take the smaller one minus the bigger one, because you do smaller minus bigger, you're going to get a negative. So it's going to be twice what x minus y is. Take the larger minus the smaller, that's the difference, and twice that means put it in parentheses, and that whole thing is equal to 8. Well, we now have our 2 equations. Well, we got to do a little bit of work here. If you're going to add things right now, we better distribute first. So I'm going to rewrite these 2 problems. I got x plus 2y equals 13. And when I distribute here, I get 2x, and that's going to be minus 2y equals 8. Notice this time it's only around that set of numbers in parentheses here. Trying to fix that up a little bit. Okay. Well, if I take a look right away, who falls out? Bingo, you're right. The y's, if I just add them, I don't even have to multiply anything. So if I take the x and the 2x, I get 3x. And if I take 13 and add 8 to it, I get 21. And I quickly divide it by 3, and x turns out to be 7. So I now know the larger number is 7. Okay? And all I got to do is figure out the smaller one. Well, I like the first one better without the parentheses, so I get x plus 2y equals 13. And I'm going to put 7 in there, so 7 plus 2y equals 13. I'm going to minus 7 from both sides. I get 2y equals 6, divide by 2, and y is equal to 3. So my smaller number is 3, my larger is equal to 7, and that is my solution. You can check it out. To the larger plus twice the smaller, so if I take the larger, 7, plus twice the smaller, 6, I get 13. And if I subtract the 2, 7 minus 3 is 4, and I double it, twice that, I get 8. So I know it works if I do the check. All right, get out there now and write yourself an excellent WSQ and be ready to show us the other stuff that we had in class here that you were supposed to do on your own. Have a good evening. Have fun.